Hi, I'm Ardeshir. I'm basically a software engineer at Funding Circle, and what I'm going to talk to you about is how we basically managed to build and deploy a Node.js sort of serverless application in less than 2 days. So as you can imagine, usually always starts with some sort of idea. You think about a particular problem that you feel it's worth solving or you can do something about. As software engineers, we are problem solvers. So we try to solve problems, but what actually happens is whilst we try to solve problems, we either create more problems or make things more complex. This is because, I guess, we have a tendency to sometimes oversimplify or sometimes overcomplicate things. Say you were thinking about building some sort of application. You've already started coding your application. So you think you're going to use Node.js because you always choose the right tool for the job. It's not because you like JavaScript. Your app needs some sort of storage. Obviously, there's a lot of options for that, but I'm not going to talk about any of the names today as much as possible. So you pick a database. You kind of go through the process of basically choosing a UI framework. You don't want to use a UI framework to begin with because we got ES6 these days, so you can just use vanilla JavaScript. It's quite cool. But you have some kind of ideas on sort of using React because you've explored these new features of React you're quite excited about, but you're going to keep it simple, right? It seems you're on the right track, correct? I mean, before I forget, obviously you also care about other things like local development environments, so you want to make sure that you can, set up a local development environment, and you want to also run unit tests because you love TDD, right? Or is it just on your CV? So it seems like you kind of have covered everything. But wait, are we not missing anything else? Right, how about CI and deployment? Where is this app going to run? Like, is it going to just run in your basement? You got a server in your basement? I think most of us don't even have a basement to start with. So obviously we have cloud, so we can use cloud services, but we still need some CI tool or something similar to run our tests, build, deploy, what have you. So you need to choose something like that. So imagine your service in the beginning is just one service. So you have this Express application serving front end. So it's quite simple. But clearly you are thinking in the back of your head that you might want to separate it to two different apps. But we want to keep it simple for now, because as engineers, we actually love simplicity, don't we? So then what? Like, where is this actually going to run? So now you're kind of drawn in the overwhelming number of options you have. Which cloud provider is good? Should I use virtual machines or should I use containers? I have played a little bit with containers or Docker on my local, so it should be easy enough. So you think about it. And obviously VMs used to be the approach back in the day. You kind of bake images in the cloud and put your application there. But you're thinking about all these options. You're also thinking maybe there's a lot of pain with setting up containers or VMs, so maybe you can use a platform as a service. I also can think about all sorts of other options. You can imagine this list goes on, and there's more and more and more things you can do. So are you not just overthinking this? Like, imagine none of these things would really matter to your user. Like, what if you have spent all this time to set up a very good sort of infrastructure, local setup, golden infrastructure, testing strategy, monitoring, all that jazz. And once you release your app, you realize basically it's absolutely rubbish or useless. Imagine how much time you have wasted in this process. So, is there any hope? Like, there's a question. And before I actually explore that, speaking of amount of time spent on setting up environments, I kind of remember a memory from years back when I was trying to deploy my first Node.js app. It was a bookmarking app. So basically, back in the days, I had this free cloud service, sort of cloud VM thing. So what I would do was, pushing the code to Git. I was using version control, so it fair enough. I mean, I wasn't kind of copying things from my local to the server. So I was basically pushing the code to the version control. I would then SSH into the server, then pull it from there, and then set up all these funny Linux services to allow running this in the background and daemonize it. Don't want to go through that. But basically, you can imagine that for me it was very, very kind of time-consuming to do all of this. But I was really enjoying it. I thought this is the normal way of doing things, and you have to do it. Everything looked really cool until it would just break for no good reason, and then I had to go back, like look at the logs, see what's going on, restart things over and over again. And eventually what was happening was I realized I'm spending a lot of time just going through infrastructure work and not spending enough time on improving the application itself. So fast forwarding today, I'm thinking about how I would have approached the same problem. What if there was an easier way to run and basically deploy the application whereby I was not kind of spending a lot of time on this type of things, and I could literally quickly iterate on the application, put it in front of some actual users so they could actually have a play with it, and I could validate some of my ideas. And that is how I came across serverless. Raise your hand if you haven't heard about serverless. I assume most people have done. Like I guess maybe this is not the first talk in relation to serverless. I've just in case put some sort of definition coming from the good old Wikipedia here. I'm not going to read it all, but just like parts of it. So the function as a service is a sort of a cloud computing service platform that allows you to develop, run, and manage applications without the complexity of worrying about infrastructure. So in short, serverless is a platform that allows running apps and focusing on building the application without worrying about infrastructure complexities there, which is kind of typical to most apps. So how does serverless work? Again, this is not a talk about how serverless work, but I just assume that maybe I come up with some sort of a high-level definition or explanation. So what happens is you basically build and implement your server-side code. This is quite similar to any other sort of thing that you build. You upload the code, package it into the cloud, and then it runs in some sort of stateless container, if you like. And how it gets invoked or executed is by just some events that could be different things. And generally speaking, it's ephemeral. So it means like the data is short-lived, and if you want to persist anything, you need to kind of worry about it in a different way. So some of the very fundamental benefits of using serverless are reduced cost. This is the thing that it promises to give you. It could give you that because in principle, you don't have like several idle times, and you just pay per kind of usage or execution. And the other thing is the auto-scaling, which comes out of the box. So that's about as far as I go about describing how serverless works. So should we care about this? And what does that mean for us as JavaScript developers or front-end developers or generally developers? Let me tell you a story. At Funding Circle, we do hackathons every once in a while. So what happened was during the last hackathon, a group of us came up with this idea of building a smart image resizer. Smart because it could detect faces in the image, and then what it does is it could crop the image by taking into account where the face is and kind of position the face in a desired sort of place in the output. When we initially came up with this idea, the question raised was that, can we manage to build, test, deploy all of this in less than 2 days? Because that was the kind of hackathon's time that was given to us. And clearly, we did not have any sort of time for setting up infrastructure or any other thing, so we had to clearly just focus on the code and the logic. So we knew this was going to be written in Node.js. This is not because we just like Node.js. It's because as a team, we felt we were more familiar with JavaScript stack. And what happened was also knowing that initially we have no idea about how the image resizer works. It was a bit of a kind of a challenge for us to be able to kind of find a solution for analyzing the image and finding the face. So we thought that might kind of be a rabbit hole and take a lot of time. And then one thing you might ask is, why do we kind of choose to build an image resizer, right? Because we know there are other solutions out there. And the simple answer is saving money. We already use AWS, and we did not want to pay another bill. Also, we needed some sort of customization for the particular use case we had in Funny Circle. So we wanted to build it in a customized way. And we also did some sort of budget forecasting thing that comes from AWS, and we realized that we could save 8 times more in terms of the cost comparing to another service called Cloudinary. I don't know if anyone heard about Cloudinary. So it's kind of a software as a service that gives you the sort of similar feature set. And honestly, I mean, the numbers are there, but I don't really trust Amazon with numbers. But I mean, there was a business case there, clearly. If not 8 times, maybe like 2 times. So containers or serverless was another thing. Although we were kind of keen on serverless, but we actually initially considered maybe we can use containers. But then straight away, we realized we got only 2 days and we don't have a lot of time to set things up. And imagining every time we have to deploy changes, we need to build a new image, things like that. So we went for serverless. And because we were using AWS, we kind of decided that, obviously we didn't decide, it was there. AWS Lambda was the kind of Amazon's function as a service kind of platform. So we chose, obviously, AWS Lambda. But basically, there was another requirement we had, which was, because this was like a Resizer service, it had to be exposed in some web pages and used. And we needed some sort of HTTP sort of URL for this, or API interface. So we knew that you could do it separately on Amazon, but we wanted to find a tool which would abstract away all the complexity of having an API, which then uses Lambda. So basically, we came across a serverless framework. So I don't know if anyone has used serverless framework. You could raise your hands. Okay, that's pretty good. So basically, serverless framework is an open source software that allows you to build, compile, and package, serverless applications, and it kind of abstracts away some of the complexities that are necessary to set them up. And it is kind of quite cloud agnostic, so you can use serverless framework with most of the cloud providers. And what it usually does is allows you to set up events. Those events can be anything, any type of events. It could be like a cron-like scheduled event. It could be like a HTTP event. And these events will in turn invoke or kind of execute Lambda functions, which are your actual business logic. It looks very simple, right? But if you think about it, there is a lot that goes into it. Now, I'm not going to have a deep dive into the serverless in this talk, because this is not the serverless framework in this talk, because this is not what is planned. But all I can tell you in terms of how you set it up is you have to configure it. There's this sort of serverless YAML file, which allows you to define the sort of functions definitions and also the events. And then this maps into your set of functions that you define. So these functions are actually the handlers. Serverless framework, and generally most serverless platforms support multiple runtimes. In this case, we use Node.js, and as you can see, the way it works is an event comes in and then a response comes out. You might say that's easy, but we actually had our challenges to make it all work. So when we decided we're going to go for the serverless framework, we came up with some sort of architecture. And I'm going to explain this architecture from a user journey perspective. So what happens is you have this user on the sort of relatively bottom. The user could be your designer, could be like a normal developer. They will upload some sort of an image into like an image storage. In this case, it was S3, the Amazon storage. Then they will kind of use the CDN URL, which is kind of a caching URL provided with the path to their image. And they put that URL as well as whatever sort of dimensions they have in mind, like the width and height of the crop version. They provide as query params to the URL. And basically, they put it in a web page. So what happens is when this request goes out, it goes to the CloudFront, the CDN solution. it will either be served by CloudFront, which is in case it's cached before, but if it's not cached, it will kind of fall back and go back to the actual origin, which CloudFront is configured to. In this case, that origin is our serverless stack and application. So what happens is this request goes to the API, the smart Resizer API, which will then, as I explained earlier, it will create the HTTP event, and it will trigger your Lambda function. Now, in this case, the Lambda function will pull the image from your storage. So both the developer and your Lambda function have access to the storage. It will pull the image, and then it will kind of make a call to your image analyzer AI, which will then analyze this image and come up with all the faces that it recognizes in there. It will come up with some sort of metadata back to your service. Your service will take that into account, and it will crop your image. And then it will return the sort of cropped binary back to the API, and then API in turn to the CloudFront, and CloudFront will cache it, and then you will see the cropped version on the web page. So that's more or less how it works. Over-engineered, you might say, right? You think so? To be fair, we did think about that in the first place, and as our sort of minimum viable version, we did think that we might not manage to do the caching, nor we could potentially finish the image analyze AI. But guess what happened? We managed in time. We got enough time to build all of it, and it was really good. Here's just a very simple example. On the left, you got this original image. You see our favorite character, Captain Galactic. It's like our branding superhero. And then you got the cropped version of it on the right. You see one normal sort of crop, like sort of resized version, and the one on the sort of towards in the end is the actual smart version of it, which actually recognizes Captain Galactic as a face and crops around it. Quickly describing how we test deployed and did integration. I think testing-wise, we use this plugin from Serverless calling Serverless offline. Essentially, we didn't do any automated tests because we didn't have time. It's a shame. But this Serverless offline allowed us to run the service locally and try to, build the code on top of it and manage to have some sort of exploratory testing, and then we could then deploy and see how it works in the cloud. Deployment-wise, we didn't set up a CI. What we did was basically just relied on Serverless Framework's CLI deployment, which was quite easy to use. The only additional bit was using a sort of running this in a Node 8.1 container just to make sure that we use the same runtime version as what the AWS Lambda was using, because sometimes you get some funny things when you don't do that. And the last thing was our integration with the image analyzer AI. This integration was with this service called AWS Recognition. So AWS Recognition, just that you know, as a sort of API managed service in Amazon, allows you to make deep learning image analysis. So it has pre-trained models that are already there running, and it will give you very, very useful kind of information. I think our use case was really simple. So basically, we just wanted to detect faces, and there's a lot more you can do with this. We had some challenges, namely, we wanted our response to be binary because this is basically image resizer. It has to return a new image, right? And this is not plain text. Usually, when you write Lambda functions or use Lambda, you kind of are either creating JSON APIs or XML or like, I don't know, HTML, whatever. It's plain text, so we wanted binary. And it was initially a bit of a challenge, but then we kind of researched and found the right plugins. The good thing with Serverless Framework is there's so many additional plugins that gets attached to it, and you can develop plugins. They work like hooks. They run during building, deployment, and different sort of stages of the serverless sort of lifecycle. And I think I'm not going to go through that, but generally just search Serverless Framework plugins. Quite interesting. So what did we learn as a team? I think the most valuable thing we learned was that we realized that with little or no upskill, we can build these applications using Serverless Framework. I can give you some context because the team which was working on this, we were mainly like more skilled in the front end side. We had little or some experience on Node.js, but let's say very, very little experience in infrastructure. And yet we realized that just keeping our own skill set, we are able to build applications which work end-to-end, and we could deploy it, and it could scale and work perfectly. The second thing was we were able to focus on real value. And by that, I mean, we basically were able to, because of how the serverless framework worked, abstract away all the sort of difficulties and complexities with the infrastructure and focus on the code. So we were adding small bits of code, doing a deployment. There was a very short lead time before pushing the code and running the deployment. So it was quite quick. We could get really good feedback. And this really helped us to be able to cover everything that we had actually planned to build, which was really good. And the other thing is we realized that it's quite easy to extend with features. So not only we did manage to build these features, which were the functional ones, but we also were able to just simply add a CDN cache quite easily in a matter of hours to it, which something that could not be that simple sometimes when you want to, add some caching for API was quite seamless. And we actually realized that it's quite extensible, which was really good. So is serverless perfect? There's a question, is there any dark side to serverless? There's some 3 points I'm going to touch on, which are kind of maybe some things that you already know, but I'm just going to review them. First of all, it's not fit for all purposes. When you're kind of building something quite complex, which kind of needs particular types of integrations, or it's doing something quite heavy or time-consuming, you probably could not use serverless because, first of all, it has limitations, executions, and second of all, it might just cost you a fortune. I can give another example because what happened was a few months later, we had a different requirement to build another service. It was a Node.js service to integrate with some message broker, consume some messages and then publish some messages. And for that particular use case, we couldn't also use serverless because we wanted something to be more stateful and also basically kind of run as a process rather than something that just is ephemeral and runs and dies. So that was one of the examples. The other thing is, I think, given what serverless framework does, and it kind of eliminates a lot of kind of complexities in infrastructure, still I think it's necessary to have some understanding about cloud infrastructure. As long as you're in a sort of happy path, everything works fine, it's good. But as soon as you come across some problems or troubles, then you kind of need to have some ideas about various services that you're using, things like AWS Lambda or API Gateway, or depending on what cloud provider you use, you kind of need a little bit of understanding there. And the last thing is vendor lock-in. This is compared to what you get from the containers. So with containers, you create one Docker image. This Docker image could be used everywhere. It's sort of agnostic to where you run it. Whereas with sort of function as a service platforms, each cloud provider might have their own flavor. They might define different interfaces which are not necessarily compatible. So there's no such thing as a standardization in sort of function as a service platforms. And that might mean that you need to make changes if you want to, say, move from Amazon to Google or something like that. And finally, I just want to say that whatever I spoke about today was literally around some of the examples, and it just represented the very sort of narrow, relatively limited experience we had with serverless. So I don't think there's any right or wrong in this, whether you should use serverless or not should serverless. But what I really like to leave you with is the thought of all the potential things that you can do with serverless. If you come across some ideas on building new tools or apps, it just helps a lot with solving a lot of the problems that you need to solve. And I think now is a very, very good time to play and experiment with serverless. I think now is the right time to just go further with your ideas. Thank you very much.